In the P2 exam, there's two different types of electricity circuit that they may mention. The first is a series circuit. Now, this is in one continuous loop. So you have your power source, be it a cell or a battery, and that will be in one continuous loop with all the components going around. Don't get confused if you see something like this, so a voltmeter connected in parallel. A voltmeter has to be in parallel. It measures the potential difference. Now, the potential difference is the difference between the energy going into an appliance, a component, and the energy coming out. So you need to know what goes in, what goes out. So it has to be at the start and at the end. So I like to call it a hugger. Okay. And there's two rules for this. So you've got current. So current in the series circuit is the same wherever you go. So wherever you put this ammeter, it's always going to read the same current. However, for a potential difference, it's going to be shared. So doesn't necessarily mean evenly. Each component can draw different potential difference. But as you see here, this is 6 and this is 3. The potential difference within a series circuit will add up to the total voltage supplied by the actual power source. So they're kind of opposite. So current is the same, whereas the potential difference gets shared. For a parallel circuit, it's the other way around. So a parallel circuit is whenever you see branches, they sometimes call them, coming off, it's parallel because obviously they're parallel to each other. When you actually make it in class, it never looks like that because the wires are so wriggly. But again, this doesn't necessarily mean that's in parallel there. It's just a voltmeter has to be connected in parallel to the component. So for this, the current in this one is shared. So if I had a current here of 0.4 and a current here of 0.4, well, if I made that a series circuit, that's fine. It would be the same wherever I went round. But as soon as it splits off, this current then gets shared. Again, not necessarily evenly. So you see the bottom branch has a current of 0.3, whereas this branch has a current of 0.1. If you add those together, it gives you the 0.4. So sometimes in an exam, they might give you this one and one of these and ask you what the current is there. So it's just a process of minusing one from the other. In a parallel circuit, though, the potential difference is the same wherever you go. So the potential difference on the components will be the same as what was supplied by the power source. Again, it's the opposite. So a series current is the same, but parallel current is shared. A series potential difference is shared, whereas for parallel, the potential difference is the same.